Hi, very welcome back to our channel. And as you can see on your screen, we have got this new circuit. And this circuit is called a switching circuit. And we use this circuit quite often in analyzing the network theory applications. So we have a network as shown, and we have got switch right here. Let me show you. This is the switch you have, and then we have one voltage source. We have a resistors, that is 1 ohm and 2 ohm, and then we have this 1 Henry value of an inductor. So here at t equal to 0, there is some condition that is shown right here. So let us first read out the problem statement and accordingly try to find what is asked. So the problem reads as below. In the circuit shown, switch S was closed for a long time. So it means the switch is set to be closed for a long time. If the switch is opened at t equal to 0, so at time t equal to 0, for example, here on the axis, you have a time t. So let me draw it here. So use, for example, this is time, okay, in second, and this time starts at 0. So at t equal to 0 right here, your switch right here, switch is opened right here. And before that, that is t equal to 0 minus, okay? That means this time here, the switch is closed. So that's what the problem read before. The switch is was closed for a long time, and the switch is open at t equal to 0. Then we are asked to find the maximum magnitude of the voltage VR. Where is the voltage VR? Right over here. You have this voltage across the resistor, and we have to find the magnitude of this voltage. That is what is asked here. Okay. So here in the fill in the blanks, we have to find out. So clearly this time left to this line is t equal to 0 minus, that is on the line the time is t equal to 0, and to the right side of this the time is t equal to 0 plus. So we have got three time: t equal to 0, t equal to 0 minus, and t equal to 0 plus. Okay, so at this case the switch is closed. At this case switch is opened, and at this case then obviously from 0 second onwards switch remains opened. Okay, that's what. So how to find the voltage VR, the magnitude? So what we'll do, we'll draw the circuit before the when the switch was closed for a long time. So we'll see how the circuit looks like. So there is your Vs, that is equal to 2 volt. Then this switch is closed. So let me draw it properly right over here. So here is your switch and it is shown to be closed. So switch is closed. And then you have got this 1 ohm of resistor. And right here you have got this 2 ohm of resistance. Now, how does the inductor behave when the switch was closed? So we assume that the steady state condition for the inductor has been reached. So the fact is, in steady state, inductor acts as a closed circuit, okay, or a short circuit. So we'll say that here the current through the inductor IL, that is 0 minus current, that is at the time t equal to 0 minus, when the switch is closed, this is the current, that is inductor behaves as a short circuit. Okay, and then now you have this circuit completed. So obviously this circuit is we can see that there is this resistor also gets short circuited because IL of 0 minus, inductor acts as a short, making this 2 ohm resistor also acts as a short. So obviously the the current IL of 0 minus or the current in the circuit that we can find out will be voltage divided by the total resistance, that is 1 ohm. Okay, so that comes out to be 2 amperes. 2 amperes is the IL0 minus current. That is the current flowing through the circuit, and which is the current flowing through the inductor. Okay, now this is the case when t equal to 0 minus. Now we have to draw the circuit at t equal to 0 plus. So what I'll see is, so because I now say that at t equal to 0, the inductor, the circuit switch is opened. So this is the case when at t equal to 0 minus, and now we'll draw the circuit right here when the switch is opened. So here is your switch that is opened again at t equal to 0. So this is your switch, and at t equal to 0, and here I forgot to mention at t equal to 0 minus actually. Okay, the switch is switch was closed. So here you see that now you have got 1 ohm, and here you have this 2 ohm resistor, and will represent the inductor as a current source supplying 2 ampere of current. So here is that current that we have calculated when the switch was closed. Okay, so now inductor is acting as a current source here, and here you see that the switch is open. So obviously this voltage source, as if it's not in the circuit, so it is cut off from the circuit. So here is your circuit right here. Did I draw it properly? Okay. So now what you can do and how you analyze this circuit. Let me show you that. So obviously you can see that this current flows like this in this direction, and we are calculating the voltage drop with the polarity shown. So this is the voltage drop VR. So here we'll see that VR will be 2 ohm. That is the resistance, which is the product of I times R. So R is 2 ohm into I is minus 2 ampere. So that comes out to be minus 4 volt. And the magnitude that is asked, this is your 4 volts. So obviously, if we take the drop like this, plus here and minus here, then obviously it will be 4 volt. But now we are asked to take the drop as shown. So this is your circuit at t equal to 0 plus. Okay, this is the circuit. So you see that this is the circuit at t equal to 0 minus, and this is the circuit at t equal to 0 plus. So this is how you basically can analyze the switching circuit, in which the inductor and the capacitor's behavior can be predicted and accordingly. So in the steady state, inductor acts as a short circuit, and we saw because of that the current through the inductor IL of 0 minus was computed to be 2 ampere, and at t equal to 0 plus, when the switch is closed at t equal to 0, and then afterwards the time t equal to 0 plus, we see this form of the circuit, where we see that this 2 ampere current flows through this 2 ohm resistor, giving a voltage drop across it about to be 4 volt. Okay, now I ask you as an exercise, for an exercise, if I ask you, what I'll say, instead of the inductor, let's say there is this capacitor. So here, let's say there is this capacitor right over here in the second example instead of inductor, and then again give me the voltage VR draw. So that is an exercise for you. You do that and put your answer into the comment section. So you found this video useful, and if you did so, share it with others for wider reach, and till then, wish you happy learning. Stay tuned.